This is part 2 of our video. We're going to do one more example together in your notes. Let's go back to our vocabulary that we were using. This is from the first video, part 1, and our vocabulary words we're still going to use. And again, this is the solutions or mixture problems, and this is called the bucket method that we're going to use. Let's take a look, annotate example 2, and then what we're going to do from there is set up the problem, and I'm going to give you a chance to pause the video to try the problem out yourself. So let's read this example. Example 2. 10 quarts of apple juice. Wait, let me get my highlighter. 10 quarts of apple juice, 10 quarts, that's a number, are added to, that sounds important, 90 quarts of fruit juice that contain 10% of pure apple juice. What is the percent of pure, that's supposed to say pure apple juice in the resulting mixture? Okay, so just scanning the problem, I see that there are quarts as one of my units. I see a solution, which is 10% apple juice, and I need to find the percent of the resulting mixture. So 90 quarts, that contains 10% of pure apple juice. This is my find, what is the percent of pure apple juice in the resulting mixture? So what is the percent of pure apple juice? This is my find. This is what I'm looking for. My givens are 10 quarts of pure apple juice. Pure apple juice. So what would be my solution for pure apple juice? If something was pure, then we would have 100%. Okay. So I'm going to set up the bucket system. Remember, this first bucket is our starting bucket, our starting mixture. What do we already have? Start. All right, start in here. Then we are going to add some stuff in there, a mixture, and it's going to equal another mixture, which is the end result. So I'm starting with 90 quarts of fruit juice. It says 10 quarts of pure apple juice are added to 90 quarts. And so even though the sentence is a little weird, and if you look at the phrasing of the sentence, it says you have 10 quarts and then you're going to drop it into the bucket of 90 quarts. So our 10 quarts, are added in there. Now, what you are going to do is you are going to pause this video. I gave you a little bit of a hint and a head start. And then when you resume the video, when you're done, you can check your work. Okay, pause. And if you're coming back to the video, your end result should be 19%. So let's see how we got 19% of pure apple juice in the resulting mixture. Let's see how we did this. Okay, 10 quarts of pure apple juice are added to 90 quarts. So 100%, I'm going to write it as 100 over 100. 100%, which is another 100. And my original bucket contained 90 quarts, but it was only 10% apple juice. So I'm going to, instead of 10% and writing percent signs, I'm going to write 10 per fraction bar cent, which is 100. And the result, what is the percent of pure apple juice? That's my find. So I'm going to put an X there. And then all together, my bucket is going to have these number of quarts of juice in there. I'm going to have 90 plus 10 quarts of juice left in there. Okay. So now let's solve this problem. This will say 90 quarts that contain 10% apple juice. And so every time you have this fraction up here and you have the amount in your bucket, you're going to multiply them. So I have 10 over 100 times 90. And again, there is an invisible 1 down here, just so that we know to multiply across. Plus, I have 100 over 100. And then I'm going to multiply it by 10, but I know that there's an invisible 1 down here. And then that is going to equal to X. I know that there's an invisible 1 down here, times 90 plus 10 right here. That's where I'm going to get 100. 90 plus 10 or 100. There's also an invisible 1 down here. Let's solve this equation using our good rational expressions. techniques, which we actually don't need too much of because there are no variables in the denominator. But we do need a common denominator. So let's simplify this. 90 times 10 is 900 over 100. Plus 100 times 10 is 1,000 over 100. It's equal to x times 100 is 100x. And then we have this invisible 1 down here that we're still keeping track of. And my common denominator is 100. So I'm going to write it this way because a lot of you like to write it this way, but I'm going to multiply the right-hand side by 100. I'm going to combine this left-hand side, and I'm going to get 1900 or 1900 over 100 is equal to, I got to multiply this, so it's going to be this many zeros, x over 100. 1, 2, 3, 4. 1, 2, 3, 4. Okay. 10,000. I have the same common denominator, so that means I can set my numerators equal to each other. Now I just solve for x. I'm going to divide by 10,000 and divide by 10,000. One more. Okay. I'm going to end up getting with x over 1900 over 10,000. That's 1,000, 10,000. Okay, let me show you how to turn this into a percent. If we can get our denominator to be per 100, then our numerator is going to be our percent. So let's see, this 0 cancels out because that's a factor of 10. This is also a factor of 10, and I'm left with 19 over 100. So 19 over 100 is equal to x. So now this means this is 19 per 100 or 19%. Isn't that nice how that worked out? But this would not be complete without giving me context to your problem. What does this 19% mean? And this means the resulting mixture will contain 19% of pure apple juice. Okay, at this point, if you have any questions, for example, if you have questions about the part where I went from this fraction to a percent, bring those to class. Otherwise, go back and annotate your notes. If you were able to pause the video and then find the percentage and then watch the video just to check your work, excellent job. Bring your summary to class. Your last item of business is to write your summary. Highlight the most important parts. Also in your summary, you can include the parts that you think you're going to have trouble on, like your caution signs. If you're like, oh, be careful right here, you can include that in your summary as well. Go back and annotate your notes, write questions, write notes to yourself so that your future self, when you review these notes, will be able to quickly scan and be like, oh, that's right. After I solve for X, I need to write a sentence. Or I need to remember that percent, if I'm looking for a percent, I need to find a denominator of 100. Those types of annotations should be included in your notes, and we will check them the following day. Okay, bye.